Welcome to the course Excelling with Mathematical Modeling. In my last two lectures, we have learned about the basics of Microsoft Excel. Today we will be continuing that, and we focus on how to solve a differential equation with the help of Microsoft Excel. Now, when we try to solve a differential equation with Microsoft Excel, the solution will be of numerical type. So, I will give you a numerical formula which we will be using in solving the differential equation with the help of this Microsoft Excel. So, what I am going to derive is Euler's method of solving a first order differential equation. So, you consider a differential equation of the form dy dx is equal to fxy and given a initial condition y x0 equal to y0. Now, either you know a method of solving that, or otherwise you won't be able to solving that when you have to take the help of numerical methods if it cannot solve it analytically. So, to solve this by Euler's method, let me draw and explain. Say you have curve like this. This is your initial condition, some x0, y0. So, when I say solve this differential equation, you have an initial point x0, y0. You need to find what is x1, y1, x2, y2, x3, y3 and so on, and ultimately join those points to get a graph. So, that is how your numerical methods work. So, if this is your actual point x1, y1 in the curve, then this is your x1 and this is your y1. Now, what we do is we draw a tangent from here where it intersects this point. So, this is our approximate y1. Your x1 remains same, but you get an approximate y1. So, you calculate the slope at this point. So, dy, so if I write this as x1 y1, this is the true y1 and this is the approximate y1. So, if I calculate the slope, this value of the slope is y1 minus y0 divided by x1 minus x0, and we know that is equal to your dy dx at the point x0 and y0. And from this equation, then you get this is equal to f of x0 y0. So, I can write y1 minus y0. So, I multiply x1 minus x0 into f x0 y0. If I take this distance to be h, then x1 minus x0 is equal to h, and we get y1, I take this to this side, y0 plus h times f x0 y0. So, I get a approximate formula which will give me y1 provided I know what is my x0 and y0, and this h is called the increment. So, if this is your x0, then if I add x0 plus h to this x0, I get what is called x1. So, likewise, if I want my x2, I have to add x1 plus h to get my x2. So, in the next step, the y2 you can see from here it will be y1 plus h times f x1 y1, and if I generalize this, yn plus 1 is equal to yn plus h f xn yn. So, this formula or this method is called Euler's method of solving a differential equation of first order of this form. Now, let us do this in Microsoft Excel. You have to just remember this formula. Before I continue, let me rewrite the formula here for convenience. So, if my differential equation is dy dx is equal to fxy with y of x0 equal to y0, then the formula is for getting y1 is equal to y0 plus h f of x0 y0. The example which we will take is dy dx equal to x square minus y. The initial condition is y0 equal to 0.5 and this increment h is equal to 0.1. Now, let us solve this with the help of Microsoft Excel. So, just like before, you open a Microsoft Excel sheet and we will be using this formula. So, here I put the value of h, which is equal to 0.1. So, the equation which we will be solving is dy dx equal to x square minus y. Our initial condition is at the point 0, the value of y is 0.5. So, this is say the x value, this is the y value. I make them a bit large. So, here the value is 0 and here the value is 0.5. So, this is given and this is the value of h. So, now I have to calculate these values. Now, I give an equal increment of 0.1. So, what I will write is this is equal to this plus this, and I drag them up to this much. As you can see that all of them become 0.1, which is not supposed to be. So, this is 0.1, this is supposed to be 0.2, this is supposed to be 0.3 and so on. So, where is the mistake? So, the mistake is that when I write this formula, this is C5 plus K3, where K3 is this value. This is supposed to be a constant value. And to make this value to be constant, what you have to do is, in this K3, you have to put a dollar here and you have to put a dollar sign here. So, if you write a cell number like $K, $3, then this will be taken as to be constant. Otherwise, what will happen that according to the inbuilt system here, this will tend to take all these values in the next steps and these values are zeros, basically there is no entry. So, that is why you have to be careful when you want to take this as a constant value here, you have to put a dollar sign in between. So, now if I drag from here to here, you see now the values changes, there is an increment of 0.1. Now, I have to calculate this value. This is equal to, so the formula is y0, this is my y0 plus h, this is the value h, and again I have to make this a constant, which is dollar here and dollar here, multiplied by f x0 y0. So, f x0 means this is x square 0, so this is your f xy, as you can see from here. If I compare this, f xy is x square minus y. So, this becomes x0 square minus y0. So, this is my x0 square minus y0. and my formula is complete. That is y1 is equal to y0, which is here 0.5, plus h, which is here 0.1, multiplied by f(x0, y0). So, what is the whatever may be the functional form, in this case it is x square minus y, you just put the initial values x0 and y0 here. So, in this case x0 is 0, so 0 square, which is lying in this cell, and minus y, which lies here. So, please note, and you have already observed that you have to put the formula in one cell only, and then the rest of the cell follows the same formula when you drag. So, if I place enter, this becomes 0, and I drag say up to this. So, you get values. Now, I have to plot them. So, you take the x value, y value, select up to this much, go to insert, go to the plots, and I plot this value. Either you can choose along with the points, or if you want you can just make it as a smooth. It's totally up to you. Now, I will level them a bit. So, here is the plus sign, the moment is plus sign is here. I don't like the grid lines, so I will remove the grid lines. If you want the grid lines, you can keep. The chart title is there, the axis title I want, and the legends I want. See, what does this graph mean actually? So, the axis title, I just type it here. I put this is x value, here I put y value, to keep the same format, and here I can change something like growth, some title. Now, if I want to change this legend, this one, so what I have to do is, and this is important, you select this curve as you have selected. If I select outside, this is gone. If I want to select, and you can see that this has been selected, go to chart design and then select data. The moment you select data, you will see here this y has come here. So, this is the legend. You have to click this y and go to this edit. So, here something is there. You remove this and you type here, say whatever you want to type, say let me type the word population. And if I click OK, you see that this y changes now to population. So, one more time, if you want to change this legend, you have to go to, you select this whole curve, you go to select data, you go to this population and click edit. The moment you click edit, this has come. So, you replace this by the name, say I put species and I click OK. So, see, this changes to species. So, that is how you decorate your curve. You put the essential information, that is the axis, the title of the chart, and whatever is shown in the graph. So, this is solving a first order differential equation using Microsoft Excel. So, let me write another example here. Solve dy dx equal to 1 plus 3 cos 5 square root of x minus 9. The initial condition is y0 equal to 300. So, I put my h as 0.01 and say the time, I put a restriction, say 0 less or equal to t less or equal to 10. So, for the benefit, I write the formula also, that your y1 equal to y0 plus h f x0 y0. So, the h value is already there, your x0 is this value and your y0 is this value, and your fxy is equal to 1 plus 3 cos 5 root t minus 9. So, everything is there and you just use the formula. So, for practice, let us solve this again with the help of Euler's method using Microsoft Excel. So, I put h equal to 0.01, that is your step 1. The next step is the x values and the y values. So, this value is 0, this value is 3000. If I want to calculate this, I put equal to, that is x0 plus h, which is this, and as explained before, I have to make this a constant value. So, I put a dollar here and I put a dollar here, enter, and I get this. So, I drag them, so a little more. So, I can go from 0 to 10. So, I choose some number. Now, to calculate the value of y, I have to use this formula, that is y1 equal to y0 plus h times f x0 y0. Now, this one, which will be equal to y0, which is this, plus h times, and I have to make this constant. So, I put a dollar here and I put a dollar here. So, this is h multiplied by f x0 y0. So, this is my function f x y. So, I have to put x0 and y0, the values here to calculate. The function is 1 plus 3 times cosine cos, and you can see that has come cosine, then 5 times square root sqrt, so it has also come square root of root, this should be root x actually, considered to this x. So, this is the x value x0 minus 9, and the bracket closes. Let us see, this is the first bracket, this is the cosine bracket, and ultimately the final bracket, and it gives me a number. So, then as I drag this, say up to this much, and it gives some values. So, now I have to plot them. I go to insert, I go to this curve and I plot them. So, you get a curve here. If you want to change this, say you want to change the steps because you feel that these values are quite close. So, if I change this number to 0.1, and just click it outside, you see everything changes. So, these all values have been calculated. So, when you want to change any data, this will be automatically be applied to all the cells and to the curve. So, if I take it is to be 0.1, then I get a lot of more dynamics, but if it is 0.01, then all I have to do is I have to calculate more values. So, you get this curve, and as usual, if you want to label it, so I don't like the grid lines, I remove it. I like the legend, I have the chart title, I want the axis title. So, as usual, you can type your axis title here, say x value, here it is y value, sorry. So, y value, here it is x values, as usual you can type the chart title, growth, and if you want to change this again, you have to select this curve, go to chart design, select this data, select this y, go to edit and edit this, and I write say population. The moment you click OK, you will see that this has changed to population. So, that is how we solve our first order differential equation with the help of Microsoft Excel. Our next step is to solve a system of differential equation, first order. So, for which I will explain the theory quickly. It is just the extension of the formula. So, here we now solve a system of differential equation, system of first order differential equation of the form dx dt equal to f1 xy, dy dt is equal to some f2 xy, with the initial condition x t0 equal to x0, y t0 equal to y0. If we use the same Euler's formula, we just extend it and it will be of the form x1 equal to x0 plus h times f of x0 y0, y1 equal to y0 plus h times f2 of x0 y0. So, with this as the formula for a system of differential equation, in this case 2, we now solve the example dx dt is equal to 10 minus x minus y times x, dy dt is equal to 15 minus x minus 3y into y. Our initial condition x0 is 4, y0 is 4, and we take the increment h to be 0.1. This is the range for t. You can keep your t values in between. So, let us solve this using Microsoft Excel. Let me rewrite the problem here. So, you have to solve dx dt, which is equal to 10 minus x minus y, dy dt is equal to 15 minus x minus 3y, your x0 equal to 4, your y0 equal to 4 and your t lies between 0 and 7, your h is 0.1. Let's solve this. So, as usual, I put the value of h to be 0.1. This is t, this is x, this is y. Make them a bit large, center them. So, this value is 0, this value is 4 and this value is 4. So, I give the increment, this is equal to this value plus the increment in h. I have to make this a constant. So, you put as dollar, enter, so you get the increment, you drag up to few cells and you get the increment. Though I am supposed to go up to 7, but you get the point that I can drag this up to 7 also. Now, to calculate this x, this is equal to x0, which is this, plus h times, again it is a constant, multiplied by f t0 x0. So, this is your x and y's multiplied by 10 times minus x, which is this, minus y, which is this, and this whole thing is multiplied by again x and enter. So, you get this value, you drag it up to here, again here this is equal to y0 plus h times multiplied by 15 minus x minus 3 times y multiplied by y. Okay, let's just quickly check this. Yeah, this is one. So, now let's plot this. Go to insert, click this and this chart. So, now you get this curve. As usual, if you want to label it, you have this axis title, you have the legend, you have the axis, you have the chart title. So, again if you want to change this, you just click this, go to chart design, select data, series 1, edit, and you type as species 1 and this becomes species 1. You click this, go to edit and type species 2. This becomes species 2. This you type as time, this you type as population, and you can change the title to population dynamics, and you get this curve. So, both of them starts with the same initial condition and reach to certain values. So, now you have an understanding that how you will be able to solve system of equation or a single equation with the help of Microsoft Excel, and we will be using this to solve our models which we are going to study in our future classes. Till then, bye bye.